Hello everyone, welcome to the fourth video of the Digital Eagles programming team training. In today's lesson we're going to be going over command-based programming. So let's jump right in. What is command-based programming? Command-based programming essentially, so what command-based is a way of structuring your robot project, right? So whenever you create a new robot project in VS Code, you would select the template. The language would obviously be Java, and these are the different ways that we can basically structure and create our robot. The one that the team used 2 years ago, it was the iterative robot. But in 2019, we actually switched to the command robot because of its simplicity, the fact that it is a lot more organized, and in my opinion, easier to learn. So we're going to be sticking to command robots. It's actually the most popular choice amongst other FRC teams. And so there's a reason for that, obviously, and it's just the fact that it's better. So we'll select command robot. So this is essentially what we're going to be learning today. I'm not going to create another project because I'm going to be using last year's code as an example for this lesson. So the first thing that we're going to be talking about is the robot.java class. So in the command-based structure, you get this robot.java class. Now this comes pre-generated, and it obviously wouldn't have all the other class or objects here. It would just be empty. But what robot.java is essentially is it's basically a file where you initialize all of your subsystems, right? So all of your hardware, your subsystems, all of that should be initialized in robot.java. So here in robot.java, we can see our elevator subsystem, our drivetrain subsystem, our intakes, and our cameras were all initialized here. You can see that the hatch, cameras, and cargo subsystems were actually instantiated. They were declared and instantiated, but the elevator and drivetrain were the only two that were not. And the reason for that is because the elevator and drivetrain both use motors. So we can see here they're using PWM Talon SRXs, and for some reason you can't instantiate them outside here before the robot has actually initialized. And I believe this is due to some sort of safety feature that the WPI lib has in place, just so that you're not initializing motor controllers before the robot has had the chance to initialize. So an important note to understand is that you cannot initialize motors outside of a robot init. So that's robot.java. The next one is robotmap.java. Robotmap.java is a class meant to be public and static. I realize that's a typo. We'll fix that one of these days. But basically, you want to place all of your ports and global variables / constants in this class. An example would be the camera ports or slide encoder levels or something like that. As the name implies, the class is meant to be the map to the robot. So if we go back and take a look at last year's code, we can see that robotmap.java actually contains the PWM ports for the motors, the elevator, the encoder DIO ports, the solenoid PCM ports, the auto times for the commands. This is the controller port on the computer, and then these are controller constants in order to recognize that controller input. And then here we have camera defaults and elevator defaults. So as you can see, these are obviously constants that we don't want to change. We also want the robot to be able to use throughout. And so this is essentially the map between the software and the hardware. Robotmap.java tells the robot where the motor controller is plugged in at what port. So we know that the front right motor is at port 0 on the PWM ports because we literally tell it here. So this is how it knows what to connect to. We basically say, here's what you should be referencing, what port you should be looking for. Here's where we outline that. And then we use that in robot.java when we start to initialize things. So here in the hatch subsystem, we initialize a solenoid, and the PCM port is at hatch solenoid, robot map.hatch solenoid, and that is the PCM port which we can find here, and it's port 0. So that's robot map.java. The next class is the operator interface class, or the OI.java. Here's where you basically initialize the controller and you set any button commands in the class. It's crucial that you make a getter for the controller in order to be able to access controller variables and other subsystems or commands. So what does this mean? If we look at last year's code, operator interface, here we can see that we're declaring the controller, and notice that it's private. So we don't want the controller to ever be changed or overridden. The controller should just be the one thing that is instantiated here, and there should only be one instance because that's the only controller. We do not want to be getting input from something else. That would be a very bad thing. And here you can also see that we're instantiating and declaring button commands. So we're basically just creating these. We're basically mapping the buttons to instantiate these commands when pressed. So whenever they're pressed, we're just going to instantiate the commands, which basically executes the command as soon as a button is pressed. So this is where the controller essentially lives. Like I said, important that it's private. And then how do we access it if it's private? Well, we have this getController function here, which returns the controller instance after it's been instantiated, of course. And notice that there's no setter and that it's static, so we only have one reference to the controller, which is important because we don't want multiple references or overridden references. So the next thing is subsystems. So far you may be asking, okay, cool, this is how we do things, but how do we implement them? So how do I implement an elevator? How do I implement a drivetrain? Well, this is what subsystems are for. A subsystem generally describes a mechanism on the robot. For example, the drivetrain would be a subsystem. In the subsystem, you're not making any calls to functionality. That's an important thing to note. I'll repeat it again. In the subsystem, you are not making any calls to functionality. You are simply describing the mechanism behavior and its functionality. For example, the drivetrain subsystem should not make a call to drive on its own. It should only describe what the robot should do when the function drive is called. All subsystems should be named mechanism name subsystem.java. So this is another thing that's very important to note. This will most certainly be on your test, guaranteed. Mechanism name would be the first thing. So if it's drivetrain, it would be drivetrain. It's a subsystem, so we must say that it's a subsystem, capital S, subsystem.java. And this is basically important because if we ever get some sort of error, and we have a subsystem and a command, both names. So if we had a drivetrain.java subsystem and then a drivetrain.java command, because they're in different folders, we're allowed to have the two. But whenever we get an error, we wouldn't be able to tell which one is erroring. So where are we getting the error from? We wouldn't be able to tell which one is giving us the bug or which one is causing the entire program to crash. So when we say that it's a subsystem, if we ever get some sort of logging information, or some error or a warning or something, we can see explicitly that it is the subsystem and the mechanism name. So for example, drivetrain subsystem.java has an error on line 19. We would be able to know that we can go to line 19 in drivetrain subsystem.java and see that error. Whereas if it was just drivetrain.java, we wouldn't know if it's the subsystem or the command. And so that's why that's important. All subsystems extend from the subsystem class, so basically they inherit the default commands outlined in the subsystem class. And one of the important ones is the init default command, this one right here. In methods, these methods can basically be overridden. In fact, they are overridden. In this method, you should specify the default command the subsystem uses, if applicable. What this means is if you have a command that you want the subsystem to basically instantiate as soon as it is instantiated, so as soon as you declare that elevator or as soon as you declare that drivetrain and you instantiate it here, it can automatically instantiate a command which just gets executed automatically instead of having to have some sort of like button press that instantiates it. Now, this is somewhat controversial because here the basically the hatch subsystem could have had a command that is automatically instantiated when the subsystem is instantiated, and then we just wait in that command until a button is pressed before we do anything. So why do this if we can do that? Well, the importance of this and instantiating commands only when we need them, especially in something that's done over and over again. So the hatch and the cargo subsystems and mechanisms actually were just solenoids that extended and they pushed something and then retracted. And so that's why we were able to do this, because there wasn't really any state of in between per se. It was just either out or in. And so that's why we could do this. So we don't need a command running 0.02 seconds and basically like taking up space in that scheduler when we could have other commands that are there that are much more important. We only need these commands to be running when I press that button. And so that's why we're only instantiating that command when it's pressed, compared to something like the drivetrain. So the drivetrain actually, in the init default command, you can see here we're saying new mecanum drive command. So this is automatically, as soon as the drivetrain subsystem is instantiated, it's basically declaring or instantiating this command. And so once we do that, you can see very complicated code, but basically what you need to look at is this line right here, and that's that we're consistently allowing ourselves to drive. Now, obviously, we want to be able to control the robot at all times, and so it's important that we have access to that mecanum drive command as soon as possible, which is why we declare that drivetrain command in the init default command. And because we basically want to drive the entire match, obviously you don't want to stop. One of the methods that we'll be talking about later is this is finished, which basically kills the command once you no longer need to execute it. And it's false because we never want to stop running. We will always want to be able to drive. So that's basically what a subsystem is. It, like I said, it is a way for you to describe mechanism behavior. You should not be making any calls to functionality. You should only be telling the robot how it should perform that functionality. And another important thing is that you should never instantiate hardware in subsystems. Ever, ever, ever. Never instantiate hardware in subsystems, and that's just because it allows us to do this thing called unit testing, which is right here. And this is something that you didn't really get to see if you were at the live lessons because this code isn't public. But this basically lets us run tests and make sure that our code is doing what we want it to be doing without actually having the robot there. And so the only way we can do that is by passing in these things like this, which is a motor controller. We're passing in the hardware, which allows us to do that. But if we're instantiating it in the subsystem, it's going to actually try to instantiate it, and we won't be able to mock it in sort of like this testing environment. So it's going to go and try to find an actual motor controller, and when it can't, it's going to crash. And so that's why we just need to pass in the hardware as a parameter. This is actually something called dependency injection, and it's a very important thing. So just remember, no instantiating hardware in subsystems. We're always passing in hardware as parameters. So that's basically what a subsystem is. There's also this thing called a PID subsystem and a custom PID subsystem. So something that I didn't really go over is how you make these, but I went over it in the VS Code video. But if you right click and then you create a new class or command, you can basically see everything that I'm going to be talking about today. And that's the commands and then the subsystems. But there's also this one thing here called PID subsystem. And what a PID subsystem is basically it's a PID subsystem class for classes that incorporate PID control. Unfortunately, the class is overcomplicated and it's terribly inefficient, and it's hardly used by FRC teams at all. Instead, I recommend that we use either our own PID controller that we have, or use in other teams. But as of now, just stray away from it until the PID subsystem classes updated this January. And if you don't know what PID control is, that'll be the 6th video, I believe. So the next thing is commands. Commands are basically classes that make calls on hardware. So this is where you're actually calling that functionality. Like I said, this is basically the inverse of a subsystem. You should not be describing any robot functionality in this class. You should only be saying, hey, robot, do what I just asked you to, do. In order to call robot functionality, you should be referencing all of the subsystems from the robot class you instantiated, or through the use of singletons. And what singletons are is something that we'll talk about here down the page. But for as of right now, just understand that in commands, you should never, ever, ever be instantiating subsystems. So in this command, I should not say a new elevator subsystem. That all happens in robot.java, right? Because this is where the robot boots, and then this is where everything gets instantiated. If we said to instantiate a subsystem here, it might not get instantiated properly or in time for the command to actually be able to use that functionality. So it's important that we instantiate all of our subsystems as early as possible throughout the boot phase so that we can use it later on during the match. And so never, ever, ever instantiate hardware in subsystems. Never, ever, ever instantiate subsystems in commands. All commands extend from the command class and generally should have 5 overridden commands. So these are the typical commands that you'll see. There are some special cases like Titan commands, but the default commands that you should normally see and should at least be familiar with, hint, is the initialize, which runs before the execute is called for the first time. So what this means is initialize, think of that as your robot init. This is this is basically the method that runs once. It runs once before the scheduler calls execute over and over and over and over again. So what execute is it's a method that is called over and over and over again. And this is where you sort of put like your code to check controller input and things of that nature that basically make calls on that hardware. And so that initialize runs once. It only runs once before the execute is called. And then is finished is basically a method that returns a Boolean. And the second that it returns true is when the command when it kills itself. So the command is placed in the scheduler and it goes in order. And as soon as it returns true, as soon as is finished returns true, the command is basically deleted from the scheduler. It's removed. So we no longer need to run that command. It will no longer be running because it returned true. So if there's something that you need to be running the entire match, that should essentially return false. But if you have, say, for example, like a command that just raises the elevator to the first level, that command would be over as soon as you make it to that level, and you no longer need that command because you're already there. So that's when it would kill itself. So you basically be saying, is my current encoder count at some level, and if it is, then return true, and that would of course kill the commanded. The next function is end, and that runs once after is finished returns true, or the timeout has been reached in timed commands. So end. In timed commands, I should say. Timed commands are basically commands, but they kill themselves after a certain amount of time. So if I say this is a timed command, I want it to run for 5 seconds, and then after 5 seconds, remove yourself from the scheduler. So that means that the time commands don't have an isFinished function because they don't need to return any Boolean values. They just know to remove themselves after a certain amount of time. So the end command is basically like your initialize, but at the end. So this runs once after isFinished returns true or the timeout has been reached in the timed command. So this is basically the place you want to have code to basically sort of reset your mechanism. So if your elevator is all the way up and then the match ends, you obviously want your elevator to go back down, so you could have that, or maybe like a piston that you have extended and then the match ends, you need to retract. So this is where you would put your code for the end. Or maybe just because your command is done and you just need to make sure that everything is reset and in place for the next time. This is also where you would have that. The next method is interrupted. This runs if another command requires the same subsystem. So basically, because the subsystems are public and they're static, so there's only one reference and they're public, so they can be accessed anywhere. There are times when you are going to be using the same subsystem in multiple commands. And when you do use the same subsystem in multiple commands, they can't overlap. And so something that first implemented was this interrupted function. And so if, say, for example, one subsystem is using the drivetrain, or one command is using the drivetrain subsystem, and then I have another command that tries to use that subsystem, the first command will run this interrupted method, which means that the first command is no longer, it's basically paused, essentially. And it runs that interrupted code. So if there's another mechanism that depends on that, and then it's interrupted, you can sort of have like a pause function for that other mechanism as well. So this essentially just lets you catch that. The next thing is command groups. So command groups is basically like a command scheduler. Essentially, it allows you to manipulate multiple commands at once. So if there's some sort of sequential process, you can add commands to the scheduler in a sequential manner. This means that as soon as you run a command and it's done, run the next one. So for example, let's say we want to climb to level 3, and if you're not sure what I mean by that reference, it's basically last year's game or 2019's game where a robot had to basically climb to on top of a hab. It had to raise itself to a hab, and let's say there's just multiple steps to that. So we obviously like raise ourselves, and we go forward, and then we raise the feet, and then we go forward more. That's sort of like a sequential process, and we can have a command for each thing, and then as soon as one is done, run the next one, and then run the next one, and that basically allows us to do that. It can also allow us to add commands in parallel fashion, which means just running two commands at once. And this is somewhat important to create efficiency, essentially. But you can also sort of do this by just having each individual command running, just because of how fast each command is called, which is 0.02 seconds, I believe. So it's barely noticeable, and but you can have them parallel if you'd like. The next thing is instant commands. What an instant command is basically a command that runs immediately after the robot has been initialized, and this is often used to reset any functionality on the robot. So if you need to basically reset any pistons, reset any camera stuff, I don't know what you would use this for, but if you did need to do any of that or reset like a gyro or something, this is where you would do it. And you would do it in the instant command. Although if there's some sort of like software that you need to reset, like I mentioned the gyro, which is sort of like tells you the angle the robot's at, I would typically recommend doing that in the constructor. And I know I said you should never be calling hardware, but if you're doing that for like sensors or something, so if I take a look here at the elevator subsystem, we have an encoder for the elevator, and that needs to be reset every single time that it turns on. And so here you can see that we reset the encoder in the constructor, and this is basically how we get fresh values at the start. The next thing is time commands, and I talked about those briefly, but a time command basically requires a double when instantiating. What this means is whenever you create a command, or whenever you instantiate a timed command, you have to pass in a number, and that number gets used as the time per se. It's the milliseconds, and that's basically the time that it'll be alive for. Apart from that, the functionality is practically identical to a regular command. The final thing that we're going to be talking about is static references versus singletons. So static reference to a subsystem subsystems are typically instantiated in the robot.java class. So like I said, static references make sure that we only have one reference, and that one reference can be accessed from anywhere. But there's also the possibility of creating singletons, which store their instance statically. And what this means is, so you can see here, I created a class just called singleton, which may not be helpful because that might be confusing. But singleton isn't really, like, you don't have to call your class singleton. A singleton in general is just something that stores its reference, as you see here. But this could have been drivetrain or anything. And actually, we use this for the Limelight, and I can show that in a second. But Singleton essentially, like I said, stores its instance statically, but also privately, so it can't be changed. And whenever we want to access or get a reference to this instance, we use a getter, but it's a special getter in that we get the instance, and then we check if the instance is null. If the instance does not exist, then we create a new singleton, which is basically meaning we create a new instance of that class, and then we return it. So if there's an instance that already exists, then we don't need to create a new one, and we just return it. Singletons are never declared anywhere for that reason, just because it declares itself essentially, which is useful. But I'm not entirely sure why teams prefer to do this, or if there's any functional benefits to doing this. I simply use it as a stylistic choice. So if I feel that something is more of a tool rather than an actual mechanism, then I would create a singleton for it. And more specifically, what I mean by tool is just anything that doesn't manipulate hardware. So like the Limelight, which uses camera, which I consider to be more of like a sensor than hardware, like a motor controller. So that Limelight would be a tool, and it just manipulates data. And so that would be a singleton in my opinion. And that's how I wrote it last year actually. So if I open this, we can see the singleton. So here you can see it's not named singleton, it's called Limelight subsystem, and the Limelight subsystem is, there's an instance here of type Limelight subsystem obviously, and it's private and static. And then if I scroll all the way to the bottom, we can see this get instance method, which basically gets the Limelight subsystem instance, and then we're just returning the instance, and then of course instantiating it if it doesn't exist. So that basically concludes command-based programming 101. I know I went rather quickly, but I'm trying to keep these videos short. If you have any questions or need further clarification, of course, is the Digital Eagles Telegram chat that you can ask. Feel free to ask in the chat in general, and anyone can get to you, as well as I or the other lead Aditya. See you in the next one.